Hey everyone, it's David with Streaming Relativity, home of the Astro DNA Observatory. Earlier this week, I published a video about the Astrotech 115 EDT refractor telescope and why I believe that telescope is for the smart money. And in that video, we also did some prep work to get the scope ready for imaging. And today, I'm going to continue the journey to get this rig deployed and get it ready for first light, which hopefully is going to happen this week before the snow hits on Saturday. So I'm going to cover swapping out the Vixen Dovetail rail with a Losmandy D type plate, and then we'll mount a guide scope and make sure it's properly aligned relative to the main OTA. Finally, we'll mount this into the saddle of the iOptron CEM 120 out in the observatory. So this video is going to be added to the AT115 EDT playlist, which I link to in the description below. And while you're down there, go ahead, subscribe to the channel. You'll get notified when I post new content, which generally seems to be, once or twice per week. Okay, let's start with the mounting options for telescopes. So I'm going to try and simplify this and talk about the three most common dovetail rails or mounting plate types. First, there's the Vixen Dovetail, which is a narrow plate. It's about 44 millimeters in width, and it has a 75-degree cut that forms the dovetail. Second, there's the Losmandy D style plate, which is a wider plate, and it's often thinner, less height to it. It's about 75 millimeters in width, and it has a 60-degree cut for its dovetail. And in the third category, we'll just call them proprietary plates, the most common being the Celestron CGE, which is ultimately a variation of the Losmandy D style rail. And as you can see here, these plates, these Celestron CGE plates, are designed to form-fit the common curvatures of the Schmidt-Cassegrain telescopes that are on the market, mostly Celestrons. And the rail or the plate width itself is slightly smaller than the Losmandy D plate width. And I don't remember exactly what it is, but call it 74 versus 75 millimeters. So here I have a saddle from an old CGE mount. And as you can see, the plate itself slides in like a rail, and there's a combination of compression and that dovetail design that secures the OTA to the saddle. So now the AT115, it ships with a Vixen Dovetail. A Vixen Dovetail is more narrow than a Losmandy D style plate. As I mentioned, it's 44 millimeters in width, and the dovetail cut angle is wider, so it's 75 degrees. And this is perfectly acceptable. This is an acceptable design for a telescope mounting plate, but generally I would use these rails with smaller aperture telescopes, shorter focal lengths, and lighter weight setups. In fact, I happen to use the Vixen Dovetail mounting plate for a rail for my William Optics Zenith Star 61, which is a small aperture 61 millimeter refractor. It's a doublet. And keep in mind, there are a number of mounts that will feature saddles that can take either a Losmandy D style plate or a Vixen Dovetail plate. And the iOptron GEM45 is a perfect example. Here you see the Vixen rail slides into the deeper trough of the saddle, while a Losmandy D style plate can slide in the more shallow trench area. And note that the compression mechanism works for both rail types. And I can testify that this design also works very well with the Celestron CGE plates. I've run the C8 on this mount for a half of a year. Okay, so as I mentioned, the AT115 comes with a Vixen Dovetail. I chose to swap that Vixen Dovetail rail out for a standard Losmandy style D plate. The wider Losmandy design with that more aggressive dovetail angle is simply, it's a better choice, and I would recommend it to anyone who's considering this scope. A Losmandy plate for the AT line of scopes you can get one from Astronomics for about $49. Which is a bargain for these plates because they can be very expensive. And this is a 13-inch plate. with sufficient machining of holes and slots that you can position and adjust this to best fit your ring layout. I used I left the rings where they were, and I used 3 hex bolts to secure this plate to the rings. Okay, so what I did to mount my guide scope, number one, I simply swapped the guide scope that I was using with the C8, including the camera, from the C8 rig to the new AT115 EDT. If you recall from my deployment video of the CEM120, I love to keep things that work. I love to minimize the variables of any new deployment so that I can concentrate on the things that I want to concentrate on. And with the AT115 EDT, what I really wanted to concentrate on was the image setup, and to make sure the image train itself is optimized. Stick around, by the way. At the end of the video, I'm going to share a couple of subs from First Light. I did get First Light in last night, and it's actually amazing. So okay, so I took the Vixen dovetail plate that's shipped with the AT115, and I redeployed it to the top of the main OTA rings, fastened it in place. By doing so, that allows me to take the C8 guide scope and securely attached to that Vixen plate. So these Losmandy D clamps will work with either a CGE dovetail or a Losmandy D dovetail, or even Vixen dovetail, similar to the way that the GEM45 saddle works. At any rate, relatively straightforward. The thing to point out is that a guide scope, in this case I'm using rings that have 3 adjustment knobs. I'm really not a fan of this, but it's the only way to really get adjustments accomplished in a non-integrated guide scope clamping system. And this is temporary. I am shifting to an off-axis guider across all of my medium to long focal length rigs. But what I will point out is it's really important that you align the guide scope with the main imaging scope, because the main imaging scope will be natively aligned with the RA axes. The saddle and your mount will ensure that. You want your guide scope to also be aligned with that RA axis, and the best way to do that is to make adjustments before you deploy it. Make sure that the guide scope is pointing, and number one, there's no tilt up or down. That's probably the most important thing. You don't want the back of the scope to be lower and the front to be higher. So your guide scope's pointing up at an angle this way in comparison to your OTA. That could lead to cone error and issues in your guiding and your imaging session. Make sure that they are parallel, and generally speaking, make sure that they're pointing in the same direction, left and right. And you can do that by eye fairly well. One of the things that I did, what I like to do, is that when I have these screw type adjustments, is make sure I take pictures of the threads and I count the threads, and I make sure that these threads are roughly the same, and that gives me a good, and of course these threads are roughly the same. That gives me the confidence that this guide scope is positioned centered in the rings. So just take your time, do that right, and before you mount it and deploy it. It'll make a big difference in your guiding experience as well as your imaging session.
At this point, the rig was pre-assembled and ready to go, and with a step ladder, I was able to carefully position the OTA and slide the Losmandy D plate up into the saddle, and then secure it with the side screws on the CEM120. And this is doable with one person. You just need to be careful. And it felt really good to get this scope up onto the mount inside the dome. Of course, once it's up, the next step is to get it balanced. I've gone through this in prior videos. I usually do a rough balance in the RA axes first, just to make sure that the swing is safe. And then I do a rough balance for the deck axes as well. And in this case, I immediately determined that, I'm not going to have enough room to move up with the focuser in the way, so I had to rotate that. And that creates an interesting dynamic in terms of weight with the filter off center like that. But still workable. Took my time, got the deck axes also roughly to be balanced. And then I return and I go at the RA axes another time. And this was pretty good. I had a slight pull. I feel a slight pull from east to west, but it seems manageable. So with that, I did the final adjustments to the deck. And just a quick reminder, you also might have to adjust if you use your dew shield. Keep that in mind. You should balance with that in the position you intend to image in. It's subtle, but it does make a difference. All right, with that, we now have a balanced OTA, and I'm ready for first light. Okay, so we're all set up in the observatory. The AT-115 EDT is deployed, and our next step is to, using Nina, let's get some initial calibration frames. And so, obviously, it's a new camera as part of the setup and new filter wheel, etc. So we're going to go ahead and grab some bias frames and some dark frames. And so I did a little bit of research on this, and it seems that the ASI 2600 Pro performs well at two gain settings. One would be 0 gain with a 50 offset. That's actually the default setting for the camera and what ZWO recommends. And from everything that I've researched, it seems to be the setting that most people will shoot broadband images with. So that would be LRGB imaging using a gain of 0 and an offset of 50. And then for narrowband, many folks use a gain of 100 and an offset of 50. So we're going to go ahead and start with those calibration settings, so those settings for our calibration files. And if and the way I do it, basically I set up in the sequencer. I use the Deep Sky Object Instruction Set. It's easiest for me. And what I do is I just define a target. In this case, I'm shooting. I call the first target, gain of 0, so darks-0, but I take 50 exposures of infinitely small exposure length for my bias frames. And again, this is a 1x1 binning, and the gain is 0, the offset is 50. And I use, just for my own identification purposes, I'll shoot my bias through the 03 filter. It doesn't matter. These are covered. Bias frames are essentially really, really short darks. So the lens cap is on, and this is in a closed observatory. It's fully dark in the observatory. And then I do 20. I do 20 frames each of gain 0, offset 50. And I do this in increments 5 seconds, 15, 30, 60, 90, 120, 180, 240, and 300 seconds. Most of my shooting, most of the time I'm shooting, in the 30-second to 3-minute range, but I'll have a number of different options here, depending on the target and the conditions. So the other instruction set that I'm shooting here is for dark-100, so gain setting of 100. This would be for my narrowband work. And in this case, again, 50 bias frames, and I'm shooting 20 of the same exact timing exposure lengths. So this will get me the bulk of my, this gets the bulk of my calibration framework done. I'll shoot flats, which will involve each of the filters in the filter wheel, and I'll shoot them using the flat wizard if I have a clear sky tomorrow. So at the rate we're going, we should be completely ready to image by the end of the day tomorrow. Okay, folks, we're in the last step of gathering our calibration data, and that means flats. And I don't know if I've covered this in the past or not, but I do use the flat wizard to gather my flat frames for my various rigs. And just as a reminder, I think I have a video on calibration frames in the channel somewhere, but flats are necessary to resolve any imperfections that might exist in your image train, and the flats are specific to your image train. An image train is made up of a telescope, a filter, as well as your camera sensor, and you can see imperfections right here. These are motes, and this is vignetting. So this is specific to my image train, and you need to get these for all your filters. So the flat wizard is a convenient way of doing that. I happen to be using a light panel right now, and I'll image that for you and share it. But basically, I'm capturing 20 flats for each of the filters that I use in the filter wheel. So you see the broadband and the narrowband filters. And then for each one of those filters, you can specify your starting exposure for the flat wizard, maximum exposure you're willing to go to, the flat step size, how many, what unit of division will you use to increment or decrement your flat steps when it's doing its calculations, and what your histogram mean target is in terms of ADUs. I usually target something. This is not hypercritical, but I usually target something between 25 and 32,000 ADU. And what tolerance you have. So I'm pretty relaxed here. So I have 20% tolerance, which means that it will begin imaging when it can get anywhere between 24 and 35,000 ADU in each exposure. And so it goes through this process for each and every one of your filters. And as you can see, it is exposing. It's taking 8 seconds to expose on this filter, which is a sulfur filter, and actually 8.99 seconds, and it's halfway through. It's 10 of 20. It's got to do this for the remaining filter, which I believe is just my O3 filter, and then I will repeat this exact process for gain 100 offset 50. This is gain 0 offset 50. So anyway, that is my flat gathering workflow, and like I said, I'll go and I'll take a picture of the light panel so everybody knows, and I'll provide that model number that I use. Is relatively inexpensive. Most efficient way I know of to get your flat frames. So things were going really smoothly with the deployment. Well, the AT-115 EDT was up on the CEM-120 mount in the observatory, calibration frames ready to go. So weather was looking good, and here I am opening up the dome to allow the telescope to begin acclimating to the cool temps that I knew we were going to have last night. And so this is the Exploradome, and it works with a pulley system that pulls back that top shutter, and then two actuators that push out the bottom. Dome open, ready to go. And that evening was gorgeous. I mean, I just look at the sun setting on Mount Adam and Mount Eve in the background. The dome was at proper temperature. Telescope was acclimated, and really, I can't tell you how excited I am, I was and I am about imaging this year in 2024. And this is the very first night of imaging for the year. Okay, so I figured I'd share true first light. I know we all like to say first light is an image that we've created, and certainly it looks like I'm going to have a chance to do that tonight. But actually, first light is the very first time that the camera sensor is receiving light from the telescope, and until you've actually had it out, pointed at the stars, and started imaging and getting the focus right, your first light is usually pretty ugly. In fact, the first light that I had wasn't terrible. I had the focuser positioned at around 7,000, 8,000. I think it was 7,000. And if you remember, the range was from 0 to roughly 27,000. So I kind of guesstimated 7,000. Well, it turns out it's 10,350 is a good starting spot. And I'll do the math on that later, but seems reasonable given the focal length of the telescope and the rough position of the sensor after the reducer. I knew it was in this kind of range, so I was off by a few millimeters. But right now it is a little bit after 5 o'clock. It's 5:15, so it's really the sun is just going down. And we start to see some stars, little speckles of stars here, which is awesome. And I will be running an autofocus routine as soon as I have sufficient number of stars to work with. But look at that. A double star. But I do see some vignetting on the edges, which is okay. These will come out when I run the flats. You can definitely see some dust motes, a handful of dust motes up over here as well. This could be on the sensor or on the lens or the filter itself. I'm running 2 seconds on the IR filter here, so let's just see where this winds up, and then we'll start the autofocus routine on this and see how tight this can get. But I'm looking out at stars to the corners. Let's take a look. We're not in focus yet, but things are looking pretty good. It's looking like I've got the right back focus setting. Look at that. Stars are looking pinpoint all the way around. Look, we got our first satellite go through. Oh, look at that. It's gone. Love it. Love it. Very exciting. Very exciting. The AT-115 EDT is up and catching photons right before our eyes. How amazing. Okay, before I call this video a wrap, I promised a sneak preview of the subs from the first light session that I shot on January 4th, 2024. And for those who stuck around, I'm going to do a little bit more. I'm going to give you the subs, and I'm going to give you 2 stacks. And so remember, this is the first light session, and we've had 0 time to optimize this rig, so moderate your expectations, although I have to tell you, I'm actually very happy with the results. And might as well use this opportunity now to let you know that the plan for 2024 is for each month I'm going to concentrate on a different constellation, and I'm going to pick objects within that constellation that I'm interested in imaging and sharing with you guys. So for the month of January of 2024, I picked Gemini, mostly because that's my birth constellation. So I chose to, on my first light session, to image a couple of objects within Gemini. So I chose a star cluster, and I chose a very faint planetary nebula. Both are excellent targets to test out the optics of the AT-115 EDT. So let's first talk about the star cluster. I'm showing a 30-second exposure that was taken at gain 0, offset 50, and I was using an IR UV cut filter. So this is a broadband capture.
Now, this is just a screen grab of an uncalibrated sub-exposure, and the stretching was done by the software, the Fits Viewer software. So this is really, an unprocessed single sub. And as you can see, though, the stars look very good at the center of the frame as well as at the corners. And this is a sign that we nailed our back focus. At least we're pretty darn close to optimal here. Now, I ran a stack using 20 of these sub-exposures, and you can see here that the stars look, again, very good at the center. The stars are popping here as well as at the corners. I'm pretty happy. I'm pretty happy with this stack, and just so everybody's clear, all I did is I ran a little bit of noise reduction on this, and just ever so slightly some deconvolution to bring those stars to make those stars a little bit sharper. And this is not a full processing run on this. But at this point, the only thing I'd be looking at is I probably want to adjust the focuser a bit and get the focusing settings optimized here in Nina. So now let's go to the planetary nebula, and this is a 120-second exposure with the gain set at 100 and offset of 50 using the hydrogen alpha filter. And I know I mentioned it earlier in the video, but I'm shooting with the ASI 2600 monochrome Pro camera. This is actually my first session with that camera. I'm familiar with the 1600. I've used it for years. I decided to move to the 2600 to get slightly larger frames. So here is the screen grab of that of a sub, a single sub, very faint nebula. But we have a flat field all the way out to the corners, and that's another good sign of correct back focus. And I still think we have an issue here with the actual focus. This kind of looks like we could be a little bit tighter in here, a little bit of an airy disk. But we'll investigate and we'll optimize this in Nina. I think this is really going to come down to some backlash and step size adjustments. Now let's look at the stack of 20 of these subs, and wow, this is nice. So now we see that we see the whispers in the nebula. We see a little bit more detail in that structure, and we also see the nebulosity that is away from that central structure. So I bet there's a few people out there that can guess what we're looking at over here. I'm not going to mention the name of these objects though, because I'm going to cover them in detail in my next videos. And so you might as well go ahead right now, subscribe, and you'll get notified as soon as those videos come out. And with that, I'm going to call this video a wrap, and I'm very pleased with the AT-115 EDT, and I'm very excited about the imaging I'm going to do with this scope over the next several months. And so thank you so much for watching, and I will see you in the next video.